And well, here is the thinking that I propose. Thinking about those and or operators. So let's try to think about or. Well, maybe start with and. And means plus. And or means multiplication. Is that a way to think about? Is that a useful way, and is that a legal way? So those are the two questions. So let me describe now why that way of thinking is legal before we see how useful it is. So why is it legal? Well, we can think about interpretations any way we want, right? But the thinking becomes legal only if what we do using this thinking is legal, right? So what is it that I want to do? I want to do distributivity. So what does it mean? Distributivity if I think of and as addition and or as multiplication. Because this is the addition multiplication distributivity.
Before we move on, are you sure you don't have those reversed? The plus and multiplication, addition and multiplication?
Good question.
Yeah.
I don't know.
From a logic design perspective, they are reversed.
They're reversed. So your thinking is so JD?
Yes.
Is that so? Okay, so your thinking is about and being multiplication and or being addition. Right? Okay. Why don't we check both? So let's check that. What's distributivity there? Well, first we have to understand what it means, right? This distributivity law. It means that for whatever statements, because now our variables B, C, P, L are going to be some statements that are either true or false, right? So we are in the area of logic now. Statements true, false, and they are combined using operators. So distributivity means that you have statement A, then thinking of multiplication as and, B or C should be the same as A and B, or A and C. All right? I have just interpreted the distributivity law. Is that true now? Is it legal to think this way? What do you think is legal? How do you see that this is the same as that? Can everybody see that? Yes? Yes?
Yes.
Joe? Yes?
Yeah.
Okay. All right. So if that is true, then I can manipulate things, right? I can manipulate things both ways, by the way. Right? If I see two things multiplied, I can multiply them. Or if I see two products added together having a common multiplier, I can factor it. So that gives me some freedom of manipulating statements like that. Right? So can we apply that now? So using second thinking, and is multiplication or is addition. What we have here is L times P plus B times C. Not that much that you can do about it, right? Okay, let me check this way of thinking. Is that legal? So what distributivity means in this language is A or B and C should be equal to A or B and A or C. Now, is that true? Well, how do you ever check if this statement is the same as that statement? So let's analyze it this way. What does it mean that left side is true? What does it mean? Well, it means either A is true or that bracket is true, or both. Okay? What does it mean that that bracket is true? What does it mean that it is true that B and C? Does it mean that B is true?
Them combined together with the operator is true.
Yes, but if we know that B and C is true, we know that B is true and C is true, right? Okay, so true here on the left means A is true, or these together, both of them are true. Now let's see if that implies truthful statement on the right. Well, if A is true, then what? Then A is true. Will it make that statement true, that first bracket true? Yes, it will, right? If one of them is true, then either of those makes the whole thing true. So if A is true, then this is true. Is that true? Yes. If you have true statement and true statement, is the whole thing true? True, yes. Okay, well, there is another possibility though, right? For this to be true, we may have B true and C true together simultaneously. Will that make this statement true? If B is true, it makes the first bracket true. If C is true, it makes the second bracket true. If both brackets are true, and makes it true. So this true implies that true. And then we have to check the converse. If that is true, would it mean that this is true? And you just do some analysis and verify, yes, it is true. And that confirms that distributivity law holds true. If you think of those operators in a non-standard way. Although this would be a standard way, that is non-standard way, why would we be interested in this? Distributivity this way. Because it applies. If you think of OR as multiplication and AND as addition, what you have here in the original statement is sum of two things times sum of two other things, and now I can multiply. So applying this thinking, I can manipulate this statement to the form. Can you help me with multiplying through? L L or B or A L and B? L or B. Okay. And then what else? Should I continue and, or should I continue or? And, yes.
Or C.
L or C, right? So you multiply L through by B and C, and P or B, and P or C. All right? And now I have a completely different statement. Right? Well, I mean, it's equivalent to the original one. It's just the writing is different. It shows up in a different form. And then I can do something else with it, right? What can I do? Now I can apply the second thinking. And using the second thinking, I can think of and as multiplication, and all these ors as additions, and I can multiply through again. And can you imagine how long it's going to be? Multiplying 4 brackets, each of them having 2 terms. And my purpose, of course, is not to make a short statement much longer. Right? Usually it's the opposite. It's that you want to take the long statement and make it shorter. But, of course, you can make a computer manipulate both ways. You can write a program that tries to simplify things, make them longer or shorter, and that's what Google probably tries to do first. When it looks at your question, and your question is long, it tries to manipulate it to make it short, trying to interpret the operators a certain way and manipulate. So this idea of distributivity gives you flexibility working with logic. And that's just one of the applications. What do they like? So that's the end of the first short story about distributivity. The next one is going to be about geometry. And we haven't seen the product rule showing up in logic, basically because it's hard for me to think about those logical parameters being true or false, being functions of time, like continuous functions of time. Right? If you have only 2 values, 0, 1, it's very hard to make a continuous function.